Okay, welcome. Let's dive into lesson 1.2, which is talking about math and strings. So math is a class in Java that has lots of methods in it that you can use already that are pre-built in. And then strings, there's also lots of methods for you to use on strings that Java has written for you to do lots of string processing. Which is actually pretty heavily emphasized on the AP test. And so we're going to get some practice with manipulating strings in the next mini lab. All right, so let's talk about Java's math class first. So it's got all these built-in functions for you to use. Almost all of these methods need to take parameters, so you need to give them information, and then they're going to return values back at you. So for example, math.squareRoot needs to take a positive number or 0, and it's going to spit back a double at you. And we're going to look at the documentation in a little bit. If you ever forget what math methods you have available, if you just do a Google search for Java Math, you'll see a page for Java's math library. Okay, so if you do a Google search for Java Math, you can either look at the 7th or 8th edition, it doesn't matter. The math library hasn't changed too much. At the top it just explains about how this class works. You don't really need to read too much about this. Just note what we've got available to us. So there's a couple of constants. E and pi are going to be constants. And the way you get them is you would say math with capital M dot E or math with a capital M dot pi, P-I capitalized. These are constants that are closest to E and closest to pi. They're double values, okay? And then we've got all these other methods. We've got the absolute value method. We've got cosine. We've got exponential. Usually you're probably going to use POW, math.pow, for doing a to the b. There's math.min and math.max. Max and min are going to give you the greater or lesser of two numbers, depending on those two numbers you plug in. Math.random, we'll play around with random a bit. This is going to give you a random value that's between 0 and 1. And so we'll talk about how you can convert that to an integer, because this is a fraction instead. So there's all these math methods, and if you're ever curious, it tells you what the answer is. The return type is on the left, int, double. There's some other things that we haven't seen before. Mainly focus on the ones that are just int and double. Long, float, yeah, you don't really need to worry about those for this class. Okay, when you want to use a math method, you have to write that it's coming from the math library. So you add math with a capital M dot in front of the method name. So for example, math.squareRoot of 4, math.pow 2, 8, math.sine of math.pi. So these would be examples of how you can calculate various expressions using the math methods. Okay, here is a list of math methods. Again, if you want a more concise one, you could screenshot this and print this out. These are the majority of the ones that you'll need to worry about that you might consider using in this class. Though we probably will steer clear from sine, cosine, and tangent, and degrees and radians. Just know that they exist, that you can use that. Absolute value is very common. Ceil and floor are a little funky. They're going to take your number and round it up. If it's so 0.1, that gets taken to 1, and floor 0.9 gets taken down to 0. So it just always rounds it up. If it's for ceiling, floor always rounds it down. Max gives you the bigger of two numbers. Min gives you the smaller of two numbers, etc., etc. And we've got those constants over here. Okay, so this is also in page 155 of your textbook. It's table 3.2. So if you ever need to refer to it. Okay, let's do a practice problem. It uses the math library. We're going to write a method called hypotenuse that takes two integers, a and b, as parameters, and it computes the hypotenuse of the right triangle whose legs are A and B. So remember the Pythagorean theorem. To find the hypotenuse, you've got to square both of the legs, add them together, and then take the square root to get the C. So go ahead and try out writing this method, hypotenuse. You're going to have int A and int B as your two parameters, and your return type should be a double because the answer at the end requires taking a square root, so you'll have a double as the answer. So here's an example call. Hypotenuse 3, 4 should return 5.0. So go ahead and give it a test. When you're done, resume the video. Okay, so here's the answer to the hypotenuse problem. There's a lot of ways you could have done this. You could have used math.pow. So if you had done math.pow, then over here, instead of A times A plus B times B, you could do math.pow and A comma 2. That's going to square A plus ditto B comma 2, and that would square B. Or you could have just done what I did, which is A times A plus B times B. If you wanted to raise it to a larger power, then it gets tedious. So I wouldn't write it all out for higher powers. This gets saved into a variable, and then we return the answer after that. This is not the only way you could have done this. You could have also just done it all in one line, just like that. So we multiply A and A together, we multiply B and B together, we add those up, and then that gets shoved into the square root, and then we return that as a single answer. So that's a one-line method right there. Okay? So the important thing to remember for this is the method return type is double, as we're returning. And so that means we've got to return something, and we end up taking a square root at some point. That's why it's a double. Java returns doubles for a square root. Okay, let's try another one. So here's a formula for continuously compounding interest. Maybe you've seen this in an algebra class, or you've seen something similar to this in a science class. P stands for the amount after t years, P of t. P0 is how much you put in at the start. R is how much your yearly interest rate is, and then T is the years. So T is kind of your independent variable. And you can see a little graph I have over here, various compounding ones. If you do continuously compounding, that's the best. Yearly is slower, less growth. Monthly or quarterly is a little bit faster than yearly. It gets towards this e exponential function over time, over compounding closer and closer together. So let's write a method called compute interest that takes two doubles, which are going to be your initial investment and the interest rate, and then an integer for the number of years. And then it's going to return the amount in the account after t years. So basically we need to know these three values here. I'll just try and highlight them. So P naught, the interest rate those are both going to be doubles, and then the integer for a number of years, that's the t part. And E is a constant that you have access to from the math library. So go ahead and pause the video, test this method out yourself, and then check your work after you're done. Okay, let's dive into the answer. We're again returning a double because our compute interest may not be a whole number. We've got an initial amount, a rate, interest rate, and a number of years. So our method goes double initial, double rate, int years. So when we call it, if we're to test it out, we should put a specific initial amount, and then rate, and then years in that order. And then we just return, and I did this in one line, the initial rate, or the initial amount, times math.pow, math.e, comma, rate times years. So this right here, I'll just translate into math. This is the base, E, and then rate times years would be R times T. And then the initial amount in front, that's the P0 right there. So we have initial times math.pow, E, rate times years. Okay, so that's that. That's that one. Okay, so let's now talk about strings. So strings behave a lot differently from other things we've talked about, other kinds of data types, and that a string is the first kind of piece of data that we're going to call an object. So what is an object? An object is a group of related data and methods. So you're kind of combining some information and some functions together into one cohesive unit. That's what makes an object. So things that we've looked at that aren't objects are ints, doubles, and char and boolean. None of those are actually objects. Those are all primitive types, and strings, however, have a lot more going on with them. Okay, so what is the data for a string? Well, the data is that like list of characters that make the string up. So you can think about the list of characters in a string. You know, our string could be computers. So there's a bunch of characters in a particular order, and that's what makes the string. That's what makes it up. Methods, the methods are tools that can give you information about that string or kind of do stuff to that string. So you can get the version of the string that is all uppercased, so everything capitalized. You can get pieces of the string by using the substring method. You can find out how long it is using length. You can find out where particular pieces of the string live with index of and so forth. So there's lots of methods that you have at your disposal to get information about a string and to chunk it into pieces or to capitalize stuff or not capitalize, etc., etc. Okay, so to call these methods, to use them, you use what's called the object dot notation. And Java uses this, and other languages use this as well. The syntax for it is you usually have a variable string, and then you would say dot method name, and then specify any parameters that method needs inside the parentheses. So variable dot method name parameters. Okay, we'll see some examples in a minute. Okay, so the list of those methods that you might find useful for strings are on page 167 in your textbook. It's table 3.3. Char at gets you the character at a specific index. We're going to talk more about indexes in a moment. Index of, again, we'll talk more about indexes in a moment. Index of tells you the start of a given substring, or if it's not there, it's -1. Length tells you how many characters are in the string. Substring takes a piece of the string from the first index to the second index -1. So it doesn't grab the thing at index 2, it grabs the thing that's one before it. And substring takes from index 1. If you don't specify a second parameter, it just takes from that index all the way to the end. And then we have like 2 lowercase, which gets you a new string, everything lowercased. 2 uppercase gets you a new string with everything uppercased, and so forth. All right. So I was mentioning indexes, and so let's talk about what indexes are. So an index is an integer, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever, that's used to specify a location in a sequence of values. And strings, right, there are a bunch of characters, so you have a sequence of characters. The index is going to tell you which character you're talking about. So almost everything in Java, and most programming languages for that matter, start counting with index 0. So this is called zero indexing. So so when we look at a string, for example, AP Computer Science, this string, 0, the character at index 0 is the A. So this is the character at index 0. And the character at index 18, that's all the way over here. That's the E in the, oops. So this is E, this is at 18. 18. And this guy over here is at position 0. Okay? And so it just goes up in sequential order the way you might expect. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so forth. Okay? And so it's handy to have, when you're first getting used to this indexes for strings, so right above them, like I have written here, their index. So I have, because we go more than 10, I wrote another line above it that's the tens place. So we have the ones place and the tens place above it. So 0, 1, 2, as you go along here, I'll just underline as I go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is going to be index 10, 11, 12, 13, 14, 15, 16, 17, 18 is the last one. Okay, so we go 0 up to including 18 for indexes for this string. Okay, so by listing it above it, it's easier to see what each character's index is. When you're doing the string practice hits, I would suggest getting out a piece of paper and doing this. It helps a lot. Okay, let's take a look at some examples. If we use the char at method and we give it the index of 3, so here's our dot notation that I was talking about earlier. We do our variable name. Variable name is course, dot, method name. So this is the method name right here. And then the value, the parameter that we're passing in, it needs to get given a number, which index to grab from. So course.char at 3, we're going to go find index 3, that's right there. And so we're going to grab a capital C. That's what our return would be for this. And then, oops, let's erase this. If we did course.substring 611, so let's look at that. 611. So this is going to start from 6, and go up to, oops, up to and excluding 11. So we're going to stop 1 before 11, which is going to be at 10. So we're going to get 6, 7, 8, 9, and 10. So that's pewter. That's pewter right there. And an easy way to figure out how many letters this returns is that if you did 11 minus 6, you get 5 letters. So the substring that this gives back is the difference from the last number. It's the difference, the last number minus the first number. So we get 5 letters from it. If I started at 12 and went to the end, so if we went 12 to the end, then we're going to go find in the start, which is 12, and then we're going to go all the way to the end, so we're going to grab science. So course.substring 12 is going to be science because we go 12 all the way to the end. Okay. All right, test yourself. What would the output of each of the following calls be? Here I wrote the indexes above for you. So if we start with my name, which is Mr. Ackerman, you know, I want to make it about me because it's all about me, right? What would the result of system.out.println myname.length? It's actually all about you. That's why I make these videos. I make them for you so you learn something. Okay, so myname.length and myname.toUppercase, and then lastly myname.substring 4. So we're passing it the number 4. Go ahead and think what these are going to be, and then when you've got the answer, go ahead and replay the video. Okay, so hopefully you thought about it a little bit. As we count up at the top, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you might say there's 11 characters there, and you're not quite right. There's actually 12 characters there. And this is the tricky thing about zero indexing, is that we typically count from 1. So if we were to count this normally, we would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we would end at 12 characters. So that last index is actually 1 less than the number of characters there are. And if you counted it out, mr dot space, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, you get 12 characters. Okay? So it's a little bit tricky. 2 uppercase capitalizes everything. Boom. Mr. Ackerman, right? So everything gets capitalized. Simple. Substring 4, that's grabbing from 4. That would be going from position 4 to the end, so you get Ackerman out of that. Okay? So that would be, that's our output for this. All right. Let's try another one. Write a static method called lastChar that takes a string as a parameter and returns a char, so that's the primitive char, that is the last letter of the string. So whatever the string is, return the last letter. And for this, you can assume that the string has some letters, that it at least has some letters. I didn't write that down, but I'll write it. Assume that string is not empty. Okay? Because this won't actually work if it is empty. Okay, so for example, lastChar hello is going to return the exclamation mark because that's the last character. LastChar goodbye without an exclamation mark returns E, lowercase. LastChar A returns A. Okay, so go ahead and try this out, and you can test it with those calls and see if you get the right output, and then go ahead and replay the video. Okay, here's the answer. So it's just a one-liner. So public static char, we're returning a char type. It's kind of the first time we've done this. We're taking a string as a parameter. I just called my string stir. This is an easy name for a string variable. And then we return the char at of the string at length -1. So if we backtrack a little ways and we look at this, remember that the last character right here, this is at index 11. So this is at index 11, which is the length 12 minus 1. So we need to find the length, take away 1, and return that character that's there. So that's why we've got this string.length -1 gets us the correct index. You might have tried this one, return stir.charat stir.length. And what you would have found after testing it is you got an out of bounds error. And that's because you're going off the end of the string. You're trying to access the character that's one past the last character. And there's no characters after length -1, so you get this error. Trying to access values that don't exist are going to produce those errors. We're going to get those a lot, and try not to freak out. Just wrap your head around, why am I getting these out of bounds errors? I probably made a mistake when I called charat and I gave it the wrong thing. Okay. All right. So that concludes our lesson about strings, and we're going to get a bunch of practice with that this week, and then we'll wrap up this unit, and next week we're going to dive into conditionals, which are going to be super fun. So that's where our programs start to get adaptable and interesting. So I'll see you guys tomorrow.